everyone. I really appreciate the Swiss Oracle user community for selecting me. So shout out to them. Shout out to Oracle Groundbreaker ambassadors. So I'm a Groundbreaker ambassador and an Oracle ACE director. Thanks a lot to Oracle for designating me with that. Really appreciate it. So I'm the CEO and the founder of Red Pill Analytics. If you want to get in touch with me on social media, there's a few options for you there, and be honored if you did that. Just a quick few notes about Red Pill. These are some of the areas that we assist customers in building out modern data stacks. And we handle all the way from, we like to say, question to insight, and build all the platform and infrastructure in between, including the data visualization layer. These are a lot of the technologies that we use. We've delivered projects using each and every one of the technologies that you see on the screen. If any of that interests you, you can see our Twitter handle at the bottom of every slide. Reach out to us. We'd be happy to talk to you about any of this. So I like to start by just talking about what's changed, right? So many of us have been building data platforms. Maybe we called them data warehouses, and that's still very relevant, data warehouses and data platforms for years now. And what has changed? Well, for one thing, there's a lot more data. Each and every year, there's more data created in all the years combined prior to that. And that's a trend that's been happening for the last several years. So there's lots and lots of data, but there's several other things that have changed about when you take a look at the landscape inside of your typical organization and what they do with data now. The cloud is real. So surprise, surprise, we all know that. And that changes the paradigm really for how difficult it is to store data. We used to have to make decisions about what we would store forever and what we would discard and throw away. And I'm sure there's a lot of organizations that are wishing they hadn't had to throw so much data away years ago. But that's simply the fact of the matter was we didn't have the money or the capacity to store the kinds of data sizes that I'm talking about. And that infrastructure evolution has made it so that if you have the money to spend, right? I know that's absolutely a caveat, but if you have the money to spend, you truly have unlimited storage and unlimited compute with zero administration overhead. So the administration overhead of administering those things is not linear. And so we literally can store whatever we want to store. Now, just storing all that data, we have to actually process it. It's like throwing all your files in a filing cabinet without folders, right? So we do have to invest the time and the intelligence in trying to organize that data and make it available. But at the end of the day, we can store whatever we want now. Not all data is relational. You think back to when we were building data warehouses in the past, all we needed was a good ETL tool that could connect to relational databases as a source and as a target, maybe some files sprinkled in there somewhere, and we were good. But that's just not the world we live in today. There's too many other sources of data hidden behind REST APIs, hidden behind integrations with third-party vendors, data stores that aren't relational in nature, cloud buckets, and all these sorts of things, right? So thinking about just simply using a JDBC driver and a traditional ETL tool, it just doesn't get it done anymore. And not all data is corporate. So if you think about, again, looking back in the past, connect to your ERP system, maybe a CRM system that was separate, perhaps a couple of homegrown systems that were strategic to how you ran your business. All of that was relational in most cases, and that's all we needed. But now there's so many other sources of data that don't necessarily get generated by your organization. There's data we want to bring in from public data sets. There's data being generated and provided that we can buy from third parties. And we need to think about how we want to integrate those sorts of data sources into a real data platform. And it's not just the C-suite that wants data now. Everyone wants data. And if you think about what we're used to now with, with these, right? If you think about the experience that we're all used to now with mobile applications, we're used to having lots and lots of data organized at our fingertips. And why would we expect that when we walk inside our business or organization, why would we expect anything less? So we want the kind of data that we're used to in our consumer life for our professional life to make better decisions. And because the cloud is real and all the things I said leading up to this, we can deliver everyone can be a decision maker, a data-driven person inside of an organization now. And they expect it. It's not just that we enable it, it's an expectation today. And also, this is a major, major change. We used to just collect data for passive inspection, dashboards, reports, but that's not the case anymore. Data is one of the most valuable assets a company has, and they can choose to build a product around it to monetize that data. And that might be via dashboards as we're used to, that might be via mobile apps, that might be via data integrations, and that might be via feeds to partners and customers that are buying that data. So if you think about the product being the data, our data platform needs to be more than just a passive data warehouse. It needs to be an active consumer and producer of data. Think about that last one. Our data platform needs to be able to produce data to other consumers. And that's something that, I'll make the case that data warehouses don't do a great job at. And also dashboards have competition. So I've already alluded to this, that passive inspection of data is no longer the only use case, still a very valid use case, but it's not the only one. And I've only got 2 quotes from Gartner in this presentation. I won't Gartner you to death, but no longer just sitting in a dashboard with all our data is not the paradigm of the future, or even today, honestly. It's about having analytics integrated into processes, sitting right beside the screens that we use to make decisions, that we actually act on the world, right? So we need data integrated into our every aspect of our professional life, because again, it's an expectation. And every application is a possible source of data. No longer do we think about the cost and value proposition of going and getting data from some system somewhere that's not currently hooked up to our data platform. We want data from every single application because there are decisions that can be made using that data. It needs to be integrated. So everything now is a source of data. And the expectation is that that data will be available to the consumers that require it. Last Gartner quote, promise. So what am I building to here? What are the points I'm making? It's the point that simply relying on a data warehouse with a batch profile, batch capabilities is no longer going to cut it. And that's why many, many organizations are investing in what you might call event-driven processes, stream analytics, or what I'm describing as streaming ETL, to try to kind of bridge the gap between history and the future. So I like to call it streaming ETL. And it's going to seem like a, not a super sharp distinction, but I'm going to try to argue that it is a very, it's a very different paradigm, but one that you can take on, absolutely. So streaming ETL, well, what am I talking about there? So I want to just make a few very clear points about what I am talking about and what I'm not talking about. I don't just mean real-time data, right? You're never truly real-time. There's always some degree of latency. I'm not talking about simply decreasing latency here. I'm talking about a whole new way of thinking about building a data platform. faster data, I call it a symptom. Symptom sometimes has negative connotation. I don't mean that negatively. It's a great thing. Faster data is a great thing, but it really is just a symptom of the paradigm shift that I'm arguing for. I don't just mean change data capture, right? Change data capture is an important element. I've done whole talks on CDC, so I'm not going to dive into that too much. But in general, it's detecting changes in your system. That's very important for legacy applications. Modern applications don't typically require that because they're built in such a way that the REST API can be paginated on, or at least there's often change data detection capabilities built directly into the application. But for those legacy applications, turning on CDC is an important aspect, and I'll get into it a little bit. And I'm not just talking about data warehousing, okay? We need to be able to build a platform where a data warehouse is only one of the consumers of data. So the facts, dimensions, dashboards, still a very relevant use case. There's still lots and lots of customers investing in that even today, and building those solutions or re-platforming in modern cloud data warehouses. However, there are lots and lots of other consumers of data that I've already mentioned. And I'm going to argue that a data warehouse platform is not the best method to deliver data to downstream consumers. It is a downstream consumer. So I want to draw sort of a diagram of where you see the data warehouse as being just one more consumer among others. I hope that's clear. Events, right? So the sort of the two key elements of my presentation title is Streaming ETL and events. So I want to get into what do I mean by events? So frankly, events are what happen in the world, right? So they can be human generated. There's a few examples. A user interacting with any application, clicking something and generating a transaction or a page view or anything like that. Those are some examples of human generated events. And then events can be machine generated. So you think of all the IoT examples, and most of those examples down there are you would categorize mostly as IoT, but it's anything that's happening in the world automatically by an application. And if you want to try to sort of clarify exactly what I mean, an event is, basically what you would see in an API response. So you call a REST API or a GraphQL API, and the results, the payload you get back is typically an event. And if you think about the granularity of an event, it usually is an API call to an application. All the examples you saw in the last slide were probably the result of some kind of an API. A call, right? So whether the human being is clicking on a dashboard that's making a call to a REST API, or even some sort of legacy non-REST API, it's still an API at the end of the day. And those IoT devices, they're also an API call is generating an event. So you think about what is an event. An event is all that back and forth between applications at the most granular scale. So what I'm arguing for here is that we need to start thinking about processing events as they happen. That's what streaming ETL is. It's not simply waiting and running a micro batch every hour or every 30 minutes or even every 5 minutes. It's throwing out the whole concept of a batch, really. It's building a platform that processes events as they are generated, transforms them as they are generated, and delivers them downstream to the consumers who want them as they are transformed, curated, and made available. So that's sort of the paradigm shift that I'm talking about. So let's operate on the world in the way that the world works, which is with events as they are generated, process them, and made available. So if we think about, I want to sort of talk about the difference between streams and tables, right? So, and I'm going to get into Kafka and Confluent. I want to make another case here, which is I'm just using I'd argue the best solution for event-driven stream processing and event-driven architectures, but really you can use anything that has, polyglot language support, has the concept of offsets, which I'll get into in a little bit, and makes the capability of stream processing available. It can be lots of different cloud native services bundled together. But at the end of the day, as long as you can manage and process events as they happen, then any solution will work. So if you think about a stream, it's a constantly evolving set of events coming in, right? So if you want to do stream processing, you can process those events as they come in and be constantly processing as new events come in. So there's a few things we need to make that possible. We typically think, those of us that were from the sort of the legacy relational world, nothing wrong with that. Relation is still very powerful technology. But if you think about for processing data, we think of data as existing in tables at a particular state, right? You query a table, it gives you the results that are in the table at that point in time. You query a stream, and it's a constantly running process. As streams come in, you take those events off the top of the queue and you process them. So, that is sort of the what I like to call, I didn't coin it, but table stream duality. So we need a platform that makes streams and tables possible. And that's something that Confluent does. The concept of a stream is that constantly evolving set of records. The concept of a table is when you define a table in either KSQL or Kafka Streams, you simply declare what is the unique value for records, and it only stores the most recent record, right? What we think of as a table. So tables and streams are both possible in most streaming platforms, and Confluent is no exception. And so if you think, tables don't exist in the world. They're a manufactured entity in relational databases. What we are most interested in are streams of data. We need to be able to process data as it comes in. Stole this, there's my source down below. So first time I saw this slide, I just about lost it because it makes it really clear. So if you think about the scene that this is taken from, Morpheus says, do you think that's air you're breathing now? As Neo's breathing real hard after their Kung Fu session. And I like to say, do you think that's a table you're querying now? So if you think about even the Oracle database and you think you query a table, but what's the real source of truth for an Oracle database? It's the transaction log. It is the stream of events as they happened, the stream of transactions as they happen. And if that database crashes, it needs to start back up. It doesn't go and try to find the tables. To a certain degree, it does that, but it slowly rolls through that transaction log and replays events. That's what we're talking about. So even the Oracle database at its core is a streaming application to some degree. And all relational databases pretty much operate in that way. So instead of settling for the state of tables in a relational database, a streaming platform makes those that stream of events available to any consumer that wants it at any time. So that's sort of how I like to draw the distinction. So I want to talk about what all this means now, right? So I want to talk about some of the relics of data warehousing, some of the things that perhaps some of you on the line have inherited, have built in the past, and why they're not really fit for purpose today. So if you think about, I've built so many of these that I can't even count. But if you think about all the sources of data, you probably have an ERP system of some kind. Today, if you're a newer organization, you've probably assembled a set of applications that play that role. But many organizations, at least large ones, have some sort of an ERP system. They're probably using a separate CRM system of some kind. Maybe they're using the one that's built into the ERP, but more often than not, they're using some sort of a cloud CRM. And then all of the custom applications that were either proprietary or COTS applications that were built to run the business. And we would take that and we would ETL that into a relational database. I don't have the stats, but more often than not, that was probably an Oracle database. And we would build, applications, analytics applications. And we would build probably facts and dimensions, and maybe there were a lot of steps and layers building up to that, but that's pretty much, hold on here, sorry. So let's talk about some of the things that, some of the elements of that solution, or a solution like that. So we had a simplified model. This was a model that was designed for passive inspection, dashboards and reports. And that is what we were building to, because that was basically the only requirement we had. The ETL process, although some people had foresight to build several layers, what we might describe as bronze, silver, and gold in data lakes today, but raw data, slightly curated, fully curated. So there were some data warehouses that went through those stages and those steps, but many just simply went straight to building that final model. And that's really where all the history was stored. The only history we had in a lot of cases was those final models that we had. And that they were designed for batch processing. There was no way to really stream from those models. And our core underlying event that were generated in the real world was often obfuscated or transformed out of the final model. A lot of times they were aggregate tables, not at the grain of individual events. And so these data warehouse solutions were not designed, and no fault of their own, they were answering the requirements that were in front of them, but they weren't designed to be able to produce events to downstream consumers. They were designed to produce analytics, and only analytics in most cases. So these are some of the relics that we have to live with if we continue to build data warehouse solutions this way. Not to say that a data warehouse isn't an important aspect of an organization, it absolutely is, but it is only one of the consumers of data. And we need to think of a platform that will make it possible for other consumers of data to be able to consume events, and not just facts and dimensions, but truly events. So I like to show this slide because the Borg is a cube, and we often describe data warehouses as cubes. And often in the past, if you had a requirement that, for data, it had to be jammed into that platform, that solution, that way of doing analytics, really. So you could say, well, I want the raw data. Quite often, consumers were left out in the cold if they were more interested in raw data. You might say, well, why do you want raw data? Why do you want those events? Well, there's many use cases where we want the raw data. Machine learning, the most prevalent one today. Machines can't learn anything, or can't learn as much from a highly curated, opinionated downstream model. You've teased out so much of the interesting things that a machine could actually learn from a data set. So data scientists really want to work with raw or slightly curated data. They typically work in the bronze or the silver layer of a data lake. And then downstream analytics consumers usually work in the gold. So the idea that, hey, if you need data, go put in a request for a dashboard. It's just not the world we live in today. That's not the only use case that we need to build for. So how would we solve these additional consumers in the old world, right? So, finance has a requirement for data in a slightly different way, right? They're thinking about closing the books. They're thinking about whatever it is that finance people do. Sorry, I run from finance as fast as I can. And then we have mobile applications. Mobile applications making batch queries to data warehouses for data is just not a realistic workflow. Frankly, they need sub-second response times. They need their data cached ahead of time of what they're interested in. And doing that with a batch loaded data warehouse is just not a realistic use case. So we would try to solve these solutions, right? So finance says, I'll go try to get what I want from the data warehouse, but it's everything I'm interested in has been teased out. It's the history I want, it's not being stored, whatever. You can say that was a flaw in the design, but frankly, we need to support all of these use cases, and trying to design that into a data warehouse is difficult. So mobile and finance are some of the use cases that you might say that were poorly and underserved by data warehouses. So we want to be able to reuse some of the transformations that have been curated in the data warehouse that might be valuable. We don't want to process that multiple times, but we also probably want the capability to go to the event granularity of our data. And dimensional models, as I've said, just are poor sources for events. The batch load schedule, as I mentioned, makes it very, very difficult. And if we were using relational ETL tools, it's very, very difficult to provide data to all the different consumers if we're just thinking about using relational and file-based ETL tools. So one of the solutions that I've seen in the past is that these use cases need to go back to the source systems, right? So the data warehouse hasn't been properly designed to support all the granularities that a downstream consumer needs at the rate that they need them, on the schedule that they need them. So then in this use case, we have to start duplicating basic transformations. How do we construct a unified customer record from all the different sources of data? You don't want every single application going back to the sources and redoing those transformations over and over again. It just increases complexity. It increases all the ownership issues that we see with data and organizations as well. So this, although I've seen this, really what I've seen is that the consumers of data have to go back to the source in a lot of cases. Maybe they have to go back to the source and maybe the data warehouse at the same time, and put data together and process it separately. And that's just not a great state for the organization. And this is a slide from Jay Krebs from Confluent, where he, hyperbolically describes the modern organization that's trying to piece all of these different source applications and data warehouses and all these things together. And you get this sort of spaghetti architecture where there's lines drawn between each and every organization, each and every application. And I've seen this, I've lived this, I've replaced this many, many times with different approaches. So let's talk about how a streaming application, in my case, I'm going to talk mostly about Confluent, and that's Kafka underneath it, the Confluent platform, and really Confluent Cloud. But again, insert favorite stream processing platform of your choice here. And notice the subtle difference here, right? We see that the data warehouse is just one consumer of data, and the sort of hub of all of this is a streaming platform, in this case, Confluent. So Confluent, just not selling you that, just talking about what it is and what you might be looking for if you're going to try to find a good stream processing platform. Most of the things that it does are pretty important to that architecture. So be able to define schemas. When the big data revolution was happening, we were running from schemas as fast as we could. We wanted schema on read, and each and every consumer of data would put their own schema. We soon saw that all those schema on read is valuable in a lot of use cases. It's not super valuable for others. So you need to be able to support the definition and evolution of schemas over time. And the schema registry and Confluent platform does that. I would argue that you really need a SQL capability. SQL is the language of data. It always has been. Again, in the big data platform, we ran away from SQL as fast as we could. And now all of those platforms have SQL again. And if you're a data platform and you don't have SQL, you're probably in the process of adding it. So you really do want a SQL layer. It is the best way to describe data transformations and data queries. And you need to be able to support out-of-the-box connectors. You don't want to go developing connectors for each and every use case. You're going to have to probably write some for some sets of applications you have where there's not a connector, but really you need to come with out-of-the-box connectivity to lots of things. And if you look at it, this is what the platform looks like. It's a managed service in the cloud. You probably want that too. Friends don't let friends build clusters if they can help it. And so don't go doing that undifferentiated heavy lifting. Go buy a managed service. And you want to be able to describe your data flow from source all the way to target with events as the core component, event processing as they happen. And the Confluent platform makes that possible. So that disentangle word, sometimes you hear it as decouple. Decouple data consumers from producers, right? So you just produce data to the platform every application will produce its data to the data platform, and any consumer that wants it can consume it. And I use disentangle because decouple implies that there's only one consumer for each producer, and that's not the case. There can be multiple producers for consumer. There can be multiple consumers for producer. There's not a one-to-one ratio here, and that's the only problem I have with the word decouple. It's probably a nuanced opinion, but I like to use that disentangle word to properly describe the abstraction of consumers and producers. So the sources and the targets of data don't necessarily have to be on a one-to-one integration. So topics are usually, some technologies call them streams. Confluent calls them topics because they have a stream on top of a topic. But basically, a topic is a basic building block of the data, kind of like a table, with new records constantly being shoved at the end of the queue. And consumers read data from those topics. They can read all of it, or they can read just the data that they haven't seen yet. So if you think of our example for tables and streams in Confluent or Kafka, you can have that constantly evolving stream. You can read data right off that stream, or you can go and get data from, in Kafka, it's called a compacted topic, where all the records except the current one have been discarded. And so there's a relationship between those two things. So you can go get data where you want it. You can get the state of your account balance, or you can get all the individual transactions that made it up. So let's talk about how we produce events to Confluent or a data platform, streaming platform. So for Kafka Connect, Kafka Connect is a framework for building out-of-the-box connectors. So there's thousands of, that might be hyperbole, but there's lots of connectors for Kafka, and there's probably been one written since we've been on this call. But Salesforce is a hardened and fantastic producer. So you just grab that out-of-the-box connector, you give your Salesforce credentials, and all of your Salesforce data is flowing into your Confluent platform. How would you go get some of the data that's maybe hidden behind REST APIs? Often there's a lot like Salesforce, there's a connector for that application in the Confluent platform. But if you've got a homegrown REST application, if you've got anything where REST is, you can configure the Kafka REST connector to just pull and go grab new transactions through that API and produce them into Confluent. And then finally, roll your own. There's libraries, polyglot solutions for there's a client SDK for every language, probably most languages, I'll say, where you can go and write your own connector if you need to. And the cloud makes this very, very easy. So I just got a question and I'm going to answer it. So how easy would it be to migrate a systems ETL to a Kafka streaming platform? We're going to get there in just a minute. So Joel, hopefully I'll answer your question as we go. So how do you want to go and get data from your ERP or really any on-prem Oracle database? Go use the Confluent Premium. There's an upcharge for it. Oracle can't be too mad about that. They upcharge for a lot. So, but it uses Oracle Log Miner. It really is a configuration, no code required. And you can just go and pull all of your tables and using CDC, so change data capture. As new records happen, we get the complete source, all the events as they happen. We call and I'm air quoting there because one of the things I'm arguing for is that events are roughly equivalent to a payload response, and many transactional applications don't model their data models don't look like that, right? You have to write a complex join in a lot of cases to try to reconstruct an event. So simply plugging in CDC to a streaming platform doesn't necessarily take you the whole way. So remember, they're roughly equivalent to an API response. Now in Confluent and most streaming platforms, it's polyglot, so you could solve this solution any way you want, but I'm a SQL person and I would do this with SQL, and I can write KSQL based transformations. And KSQL supports constantly running SQL statements. It's streaming SQL. So when you write a query and run it, it's constantly running. It doesn't just end because you're querying a stream, not a table. So it'll be so we want to construct our invoices topic stream, and it looks something like this. So of course I removed all the complexity so I can get it on a slide, but it's create stream as select and all that join logic, and hit run, and it constantly runs until I tell it to stop running. So that stream invoices will always be up to date as new records are flowing in. This is very different from batch ETL. So in batch ETL, not only do we have to run it many, many times, right? We call that micro batch, but also we have to detect the changes from the stateful tables that query is based on. I don't have to do any of that with streaming SQL. I write a statement. I don't have to detect changes because Confluent does that for me, or any streaming platform does that for me. It's not something I have to worry myself with. So this is a very different paradigm. It is SQL, but it's very, very different. So let's talk about event consumption. So this is what I was just talking about, is that Confluent, and frankly, most streaming platforms, understand that different consumers are going to be reading that data, and they manage all of the data that you've seen. So when I go and consume data from Confluent, I can consume it. I consume it with a unique consumer group, and it knows the last records I read. And any consumer that wants to start consuming data, a new consumer group in Confluent, when they consume for the first time that that consumer group is seen by Confluent, you say whether you want all records or just read records as we go forward. So as a new consumer comes online and writes their processing data, they can go back and get all the data and then start reading the data as it comes in. So that's one of the real powers of a streaming platform is we don't have to worry about last updated columns and all of the sort of CDC messiness that we have to do in a relational database. We do need to go source data from those things, but in a streaming platform, we no longer have to worry about change detection. A streaming platform simply does it for you. So with this data platform in, and we go and we have all of these different event topics, what does this look like when we go back to our data warehouse, which is a consumer? I'll give you two options. One is you can still do relational ETL in an ETL tool, right? Something like OCI data integration, OCI data flow. We can go plug into those technologies and produce our transformations that we need for our data there, right? So if those transformations really are owned by that data group and that team or organization, then it's this paradigm is fine, right? So no one else is really interested in those transformations, so they're going to do it in their platform, and it's not really available to the rest of the organization. That's a fine use case, no problem there. But what I would recommend is that all the teams process their data within the data platform, whatever sort of data transformations they need, go do it in KSQL, KSQL DB. It's SQL after all, very, very easy to make those transformations. But also I can write any transformation processes using any of those client libraries you saw on the earlier slide. So whatever my language of choice is, I can write my transformations and run it within Confluent Platform. And so then we can do that usual data warehouse ETL that we do in ETL tools. We can push that back into the data platform and produce those to autonomous data warehouse or whatever data warehouse we want to use. And we've also made those, that sort of gold layer of highly curated data sets available to other consumers. So within this platform, I have both the invoices topic and the invoices fact topic available to whatever consumers have the access to get it and want it. I can simply consume data at whatever granularity I want. So if we look at what that looks like for our organization and those use cases that we described earlier, finance can go get, maybe they want the data from the highly curated sort of facts and dimensions data available. Just to be clear, Confluent is not the platform, even though it has SQL, that SQL is really designed for transformations, not for querying. You can query it and you can get data, but it's not trying to replace the data warehouse. It is the data processing layer that feeds the data warehouse, one of many consumers. So in this model, which I recommend, is do that ETL transformation inside of your stream processing platform and make it available to the data warehouse and any other consumers that may want it. And you see in this example, the mobile application is interested in the events. It's also interested in some of the analytics that's been produced because that data can now stream into that as soon as it's been processed. So all of these different consumers of data can now go pick the granularity that they want and and continue to, using the built-in offset functionality, continue to get the data as it's produced. So with that, do we take questions only in the QA screen, or do we take them with voice? Jasmine, can you let me know?
We're only taking them with the QA screen, but I would also have a question for you.
Okay.
You showed the Confluent case with the Confluent Cloud. Do you assume that all the sources are also cloud services, or could they be mixed, like on-prem and cloud services?
Yeah, good question. They can absolutely be mixed. So, you know, if I'm running Confluent Cloud and I want to keep everything in that managed service, which is a fine way to do it, then I would want to pull data from on-prem as well as cloud sources. But whether you use Confluent Cloud or you know, stand up your own Confluent platform, maybe you want to run it in compute in the cloud, or maybe you're even running it on-prem, you can write your own producers and run your own connectors and run those wherever you want. So normally when I go get something like we'll say the Oracle CDC connector, normally I would deploy that to the Confluent platform and run it right there. However, I don't have to. I can run that connector in a non-clustered environment, just really all it needs is a JVM, and I can push data from on-premises to cloud applications. So if you'd rather push your data, you can use those connectors and run them in a single node cluster on-prem and push data out. You could also go write your own polyglot solution in any language you want and run that any way you want. So ideally, you want to make it available for your cluster to reach into your organization and grab data, because lower cost of ownership, everything's running in that managed service, but it's not the only way in town. Can I answer your question?
Yes, perfect.
All right, thanks.
I think that's
and Joel. Oh, go ahead, Jasmine. I'll finish. Go ahead and finish. And
I just wanted to say that it's probably a lot of times the case that you don't only have cloud services, but they could be mixed a lot, yeah.
Absolutely. I mean, one day we will probably no longer have on-prem solutions. I mean, I think we all see that day's coming, probably. I don't think probably. I think, there will be no on-prem one day. However, that's not going to happen anytime soon. So Joel, you'll have to, let me know if I answered your question or if you want to follow up. And if anybody else wants to ask a question, go ahead and do it in the QA box. So Joel, I'm going to assume I answered your question, but if I didn't, just let me know and I'll take another swing at it.